numerical series and sequences. Let us see first of all the basic sequences we know so far. Number 1, 1, 2, 3, 4, 5. This is nothing but sequence of natural numbers. Nothing but sequence is a set of is a progression of is a list of numbers which progresses with a particular property. Next number here we can tell 6 means we are adding each number by 1. We are getting a new number. Next we'll take other set of numbers, other series 1, 3, 5, 7, so on. This is a sequence of odd numbers. The third set will take 2, 4, 6, 8, so on. Sequence of even numbers, so on. Now, in this topic, we are going to discuss with mainly 3 types of progressions. That is, arithmetic progression, number 1. Number 2, geometric progression. The third one is harmonic progression. This is, in short, we can call it as AP, and this one GP, and this one HP. Let us see the first one, that is AP. How it looks like, we'll see. Now, consider the sequence 3, 7, 11, 15, 19, so on. Consider also -4, -2. Let us take here -1, 2, 5, 8, so on. Now observe these 2 sequences. Any special particular pattern they are following or not, we'll see. Here 7 is obtained. How 7 is obtained means adding by 4 to its previous term. Next 11 adding 4, 15 adding 4, 19 also adding 4, so on going. Next, how -1 you got from -4? Here plus 3 I am adding. That is -4 plus 3 is -1. Next, again plus 3 I am adding to get 2. Again plus 3 I am adding. 3 I am adding to get 5. 3 I am adding to get 8, so on. Therefore, we'll make it generalized. Rather than numbers, we'll write with using some variables. Let the starting number be A, and we keep on adding some number D. Therefore, next number will be A plus D. And now add again plus D for this. Therefore, A plus 2D. Add again plus D, A plus 3D, so on up to the last term will be, see, the second term, when I say the second term here, A plus 1D you are saying. The third term when I say A plus 2D. Fourth term when I say A plus 3D, means one decrease. Nth term if I say A plus N minus 1 into D. One less than that number we have to tell. Therefore, this is the nth term of AP is equal to A plus N minus 1 into D, where A is called first term. That is the first term here. Next, D is the common difference. How you will be getting D? That is by subtracting T2 and T1, T2 minus T1, or T3 minus T2, or T4 minus T3, so on. Next, N is the number of terms. Now, where this general term will be useful, we'll take an example. Example is, consider the sequence 20, 24, 28, 32. Let us check whether it is in AP or not. How to check whether it is AP? 24 minus 20 is 4. 28 minus 24 is 4. 32 minus 28 also 4. Therefore, the difference is same for all the set of numbers. Therefore, it is in, definitely it is in AP. Now we need to find 50th term is equal to question mark. If I ask you 50th term is equal to how much? Here if I ask you say 5th term, it is very easy to tell. That is 32 plus 4 is 36. But when I ask you 50th term, we cannot keep on adding all the numbers. It will take time. That's why we'll use a formula now. What is the formula? Tn is equal to a plus n minus 1 into d. We want T50. Means n equal to 50. A is equal to we have 20. We have n equal to 50. That's why 50 minus 1 into d is 24 minus 20. That is 4. That is equal to 20 plus 49 into 4. That will be equal to, on simplification, you will be getting this as 216. Therefore, 216 will be there in the, 216 is the 50th term in the given AP. Now, sum to n terms of an AP. It is represented by Sn. This is given by the formula n by 2 into 2a plus n minus 1 into d, or Sn is equal to n by 2 into a plus l. What is L means? The last term. When first term and last term is given in the question and number of terms is given, we can use this formula. When first term, number of terms and common difference is given, we can use this formula. Now, we'll apply this formula to a question now. Example. We'll see an example how the formula is applicable. Consider the sequence 2, 6, 10, 14, so on. Find S20 is equal to how much? Sum of first 20 terms. We need to find sum of first 20 terms. Therefore, here clearly A is equal to 2, D is equal to 6 minus 2, that is equal to 4, and N is equal to 20. Now Sn is equal to n by 2, that is 20 by 2 into 2a, that is 2 to the 4, plus n minus 1, that is 19 into D, that is 4, that is equal to 10 into, yes, 72 is that. 72 into 10 is 720. Therefore, sum of the first 20 terms is 720. Sorry, this total is 80. Therefore, this will be 800. Next is arithmetic mean of A and B. In short, we can call at AM. Arithmetic mean of A and B is given as A plus B by 2. Sum of the two numbers divided by 2. Next, we'll go for geometric mean. That is, in short, we can call GM. Geometric progression, sorry. First of all, we'll discuss geometric progression. Then, we'll go for geometric mean. Now, geometric progression, how would it look like? By seeing example, we'll see. Consider 2, 8, 32, 128, so on. Next, 3, 6, 12, 24, so on. Observe the first sequence. How the numbers from the second term onwards, how they are obtained by using the previous term means, here 2 into 4 is 8, or 8 by 2, 4, 32 by 8, 4, 128 by 32, 4. Next, means the ratio between the successive terms is same. Next, 6 by 3, that is 6 divided by 3 is 2. Next, 12 divided by 6 is 2. 24 divided by 12 is 2. Therefore, what do you conclude now? If you take the general terms like variables, if you take, let the first term be a, and if you multiply a with some number, let us say r, then the next number will be ar. Next number will be ar into r is ar square. Next number will be ar cube. Next number so on. Now last term, that is nth term, will be, see when I say fourth term, ar cube you are saying. Third term you are saying ar square. Nth term you should say a power n minus 1. Therefore, nth term of GP is given as ar power n minus 1, where we know a is the first term. R is called common ratio. Ratio means a division. That's why we have said common ratio. There in the previous arithmetic provision we have said D is equal to common difference, because we are doing minus. Here we are doing division, that's why ratio. Next, n is equal to number of terms. Next, we'll see sum to n terms of a GP. That is represented by Sn. Sn is equal to a into r power n minus 1 by r minus 1. If r is greater than 1, use this formula. Sn is equal to a into 1 minus r power n by 1 minus r. If r is less than 1, use this formula, where a is the first term, n is the number of terms, r is the common ratio. That's it. Now, also we have sum to infinity. In this sum to infinity, strictly r should lie between minus 1 and 1. Then only this formula is applicable. Otherwise, sum to infinity is not defined. Therefore, S infinity is given by a by 1 minus r, where r is lying between minus 1 and 1. Remember this formula also. Next, geometric mean. In short, we can call it as GM. Geometric mean between A and B is given as GM of A and B, two numbers, is given as under root of AB. Now, next is harmonic mean. Harmonic progression, sorry. Harmonic progression, in this, numbers are obtained by the reciprocals of the numbers which are in AP. Let us consider AP series first of all. Let us consider 2, 5, 8, 11, so on. Definitely this is in AP. Now just take the reciprocals of these numbers. What are the reciprocals? 1 by 2, 1 by 5, 1 by 8, 1 by 11, so on. This is in HP now. Therefore, HP is very simple. Take the numbers which are in AP and take the reciprocals. Take the reciprocals, then that will be the resultant numbers will be in HP. Therefore, clearly the nth term of AP is a plus n minus 1 into d. Nth term of harmonic progression will be 1 by a plus n minus 1 into d. Here, sum to n terms is not mentioned. We cannot find actually sum to n terms because they will not follow these numbers. These numbers will not follow some particular pattern for getting sum. Therefore, the answer is sum to n terms is not there. Next, harmonic mean. Harmonic mean between A and B. It is given by HM between A and B is given by 2AB by A plus B. Next is relation among arithmetic mean, geometric mean and harmonic mean is given as GM whole square must be equal to AM into HM. Using this formula, if any of the two values of AM, GM and HM are given, the third value can be found. Let one example we'll take. In that example, if AM is equal to 4 Here we'll take AM is equal to 9 and GM is equal to 6. Then find HM is equal to how much? Now we'll apply, let GM be G and AM be A and HM be H. G square equal to H we have. That implies G square is 6 square, that is 36, is equal to A is 9 into H. That implies H is equal to what? 4. Also, we need to observe that always for any set of numbers, arithmetic mean will be greater than or equal to geometric mean will be greater than or equal to HM. This is equal to when it happens means when the given numbers are same, and strictly they will be greater than when they are different numbers. Hence, remember this inequality also. Next, apart from this AM, GM and HM, we have other sequences. We'll see the examples, some examples of other sequences. Number 1, we'll take 1, 4, 9, 16, so on, like this. Observe the pattern, how they are repeating me, how they are moving means it is 1 square, it is 2 square, it is 3 square, it is 4 square, it is so on. Therefore, it is a pattern of the perfect squares. Therefore, it is not belonging to any of the 3 progressions we have discussed. Next question, second sequence, 0, 2, 6, 12, 20, that's it. Now, if you observe these numbers, these are 0 can be written as 1 square minus 1, 2 square minus 2, this one, next 3 square minus 3, 4 square minus 4, so on, and the general property is n square minus n. The numbers are moving with this property, and these numbers are moving with the n square property. Next, third sequence we'll see, 1, 3, 7, 15, 31, so on. This can be written as 2 minus 1. This can be written as 2 square minus 1. This can be written as 2 cube minus 1. This can be written as 2 power 4 minus 1. This is 2 power 5 minus 1. Therefore, what is the general property? 2 power n minus 1. Next, fourth set of number, 1, 1, 2, 3, 5, 8, so on. If you observe, first we have taken 2 numbers, and what is 1 plus 1? You are getting 2. Next to 2 plus 1, you are getting 3. 3 plus 2, you are getting 5. 5 plus 3, you are getting 8. Therefore, this type of series is called your Fibonacci series.
3, 9, 11, 13, 14, 18, 24, 26 and so on. Now, let us see the pattern followed by this series. Now, it is 3 plus 6 which is 9, then plus 2, then plus 2, then plus 1, then plus 4, then plus 6, then plus 2, then again plus 2, then it is plus 1, then plus 4. Now, just let us look into the pattern followed. 6, 2, 2, 1, 4. After this 6, 2, 2, 1, 4, again it is 6, 2, 2, 1, 4. It means the series is repeating after 6, 2, 2, 1, 4. So, the next number will be plus 6, which is nothing but 33 plus 6, which is 39. So, the option C. 24, 12, 48, 144, 72, 288 and 864. Now we have to find the pattern followed by this numbers. Now looking at the first two numbers, 2 and 8. So it is nothing but 2 into 4. Similarly 8 and 24 is related by multiplying 3. And 24 and 12 divided by 2. And next is again into 4. Next is 48 into 3, 144. Then for 144 divided by 2 is 72. So next it is into 4. Then it is into 3. Now look into the pattern followed by these numbers. It is into 4, into 3, into 2. Then into 4, into 3 divided by 2. So similarly into 4, into 3 next must be definitely divided by 2, which is nothing but 864 by 2. That gives you 432, which is option A. missing number of the given series. Now, the series given is 5, 11, 24. Then we have to find the number missing, 106 and 217. Let us look into the relation between 5 and 11. If I multiply 2 to 5 and add 1, it will be 11. Similarly, the relation between 11 and 24 is, if I multiply 2 to 11, it will be 22. Then if we add 2, it will be 24. So, by looking into these two patterns, the next number will follow the same pattern. So, it could be into 2 plus 3. So, the required number is 24 into 2 plus 3, which is nothing but 51. That is option D. Minus 8, 5, minus 3, 2, minus 1 and so on. Now, we have to find the next number of the series. Just look into the first two terms. If I add minus 8 and 5, the result is minus 3. Similarly, if I add 5 and 3, the result is 2. Similarly, if I add minus 3 and 2, it is minus 1. So clearly we can say that it is a Fibonacci series. So in order to obtain the next number of the Fibonacci series, we have to add the last two numbers. So here, in order to get the next number, it is enough to add the last two numbers, that is 2 and 3. So the required number is 5. That is option B. The series given is 2, 3, 6, 18, 108. Now, in order to get the 6, if I multiply 2 and 3, you'll get 6. Now, 18 is obtained by multiplying 3 and 6. Next, 108 is obtained by multiplying 6 and 18. So clearly it is a Fibonacci series under multiplication. So in order to get the next number, it is enough to multiply the last two terms, that is 18 and 108. So if we multiply 18 and 108, the result will be 1944. That is option A. We have to find the next number of the series. Now, the given series is 99, 51, 27, 15, 9. Now, let us look into the relation between the first two numbers. 99, next number is 51. So it is less by 48. Next, the difference between 51 and 27 is 24. And the difference between 27 and 15 is 12. Similarly, the difference between 15 and 9 is 6. Now, let us look into the pattern followed by this subtractions. First is 48, next is 24, that is half of 48, next is 12, which is half of 24, next is 6, which is half of 6. So the next subtraction must be half of 6, that is 3. So the next number will be 9 minus 3, which is nothing but 6. That is option C. The missing number of the series 2, 12, 360, 174, 636, 000. Now, just look into the numbers 2, 12, 360 and 17463, 6000. That means the numbers are increasing very hugely. So we can say that it's nothing but continuous multiplication. So now let us try to find out the pattern followed by these numbers. Let us take the first digit, that is 2. I'll write this 2 as 2 power 1. Now, the next number is 12. So, as we have taken 2, write this 12 also in terms of 12. So, which is nothing but 2 square into 3. And similarly, we'll write this 3 as 3 power 1. Now, let us look into the next number, 360. Again, we'll write this 360 in terms of 2 and 3. Now, 360 is nothing but 36 into 10. Then again, 36 into 2 into 5. So, 36 nothing but 4 into 9. So, one more 2. So, this can be written as 2 cube into 3 square into 5 power 1. Now, look into the pattern. The first digit is 2 power 1, then 2 square, then 2 cube. So, obviously the next number will be 2 power 4. Now here, it is 3 power 1, 3 square. The next number will be 3 cube. Now here, 5 power 1, next will be 5 square. So, the next digit is nothing but 2 power 4 into 3 cube into 5 square. If we multiply, we'll get the value as 75600, which is option C. To find the next number of the series. The series is 3, 3, 6, 18, 72. Now, looking at the first known numbers, that is 3 and 3. If I multiply the first digit, that is 3, by 1, we'll obtain this 3. Now, if I multiply the second term, that is 3, by 2, we'll obtain 6. Now, look into the relation between 6 and 18. So, it is 6 into 3. Next will be into 4. So, obviously, the next digit will be into 5. So, the required number is 72 into 5, which is nothing but 360. That is option B. Find the wrong number of the series 0, 8, 7, 16, 14, 24, 22, 32. Now, just look into the series 0, 8, 7, 16, so on. Now, let us consider the odd numbers, that is first, third, fifth, and so on, and also even numbers 8, 16, and so on. Now, look into the numbers in the even places, that is 8, 16, 24, 32. That means the numbers in the even places are multiples of 8. Similarly, look into the numbers in the odd places, that is 0, 7, 14, and so on. So the numbers in the odd places are multiples of 7. If they are multiples of 7, then it should be 7, 0, 7, 14. Next number must be 21. Instead of 21, it is given as 22. So the wrong number is 22. That is option A. We have to find the sum of first 15 terms of the series 2 square minus 1 square plus 4 square minus 3 square plus 6 square minus 5 square and so on. Now, the first term is 2 square minus 1 square. Second is 4 square minus 3 square. Third is 6 square minus 5 square. Now, in these terms, look into the first terms 2 square, 4 square, 6 square. First term is 2 into 1 square. Second is 2 into 2 square. Third is 2 into 3 square. So, obviously, 15th term will be 2 into 15 square. That is 30 square minus 29 square. Now, 2 square minus 1 square is nothing but 3. 4 square minus 3 square, 16 minus 9, that is 7. Next, 6 square minus 5 square, 36 minus 25, which is 11, plus so on up to the last term, 30 square minus 29 square. It is nothing but 30 plus 29 into 30 minus 29, which is 59. Now, clearly the series is in arithmetic progression, whose common difference is 4 and the first term is 3. Now we have to find 15th term. So, S15 is nothing but n by 2 into a plus l. Whereas n is the number of terms, that is 15 by 2 into a is the first term, which is 3, and l is the last term, which is 59. If we simplify, the result will be 495. That is option D. We have to find the wrong number. The given series is 2, 6, 29, 146, 877, 6140. Now, by looking into the numbers, we can say that the numbers follow multiplication, certain multiplication pattern. Now, the relation between 2 and 3, I can give it as into 3. Now, 6 and 29, so it could be 6 into 4 plus 5. Next, now 29 into 5. 29 into 5 is 145, so it must be plus 1. Now similarly, relation between 146 and 877 is 146 into 6, which is nothing but 876, so plus 1. And similarly, the next is nothing but 877 into 7 plus 1 will give you 6140. So by looking into this, we can clearly say that into n plus 1 is the series. So the last is into 7 plus 1, previous into 6 plus 1, then into 5 plus 1, this must be into 4 plus 1, this must be into 3 plus 1. So the second term must be 2 into 3 plus 1, which has to be 7. Now let us look. If it is 7, now 7 into 4, next term must be plus 1, which is 29. So is it following the pattern? Yes. So obviously the next term must be 7 but not 6. So the wrong number is D. All multiples of 13 between 45 and 456. So we have to find the sum of all multiples between 45 and 456 of 13. Now, after 45, the next multiple of 45 is nothing but 52. Next 65, next 78 and so on. Now how to get the last multiple of 7 between 45 and 456? Divide this 456 by 13. Now if we divide this 456 by 13, the remainder is 1. So if I remove this remainder 1, it will be exactly divisible by 13. So the number will be 455. Now we have to find the sum of all the numbers 52, 65, 78, so on up to 455. Now it is an arithmetic progression whose first term is 52 and the common difference is 65, and also we have to find the sum. Now that means in order to find the sum, we have to know the value of n, that means the number of terms. Now how to find this number of terms? One method is a plus n minus 1 into d is equals to l, that is the last term. From this we can find the value of n, or to find the value of n, I'll give you a simple method, that is last term minus first term by common difference plus 1. This will be easy. Last term is 455 minus 52 by common difference plus 1. If we calculate as 31 plus 1, so the value of n is nothing but 32. Now we have to find the sum of 32 terms, that is S32, which is equals to n by 2 into a plus l, whereas n is 32, a is first term which is 52 plus the last term is 455. If we simplify, we'll get the value as 8112, which is nothing but option D. To find the next term of the series 1, 7, 23, 55, 109, 191 and 307. Now let us try to see the pattern followed by this numbers. Now 1, we can write this 1 as 1 and 7. 7 can be written as 8 minus 1, which can be also written as 2 cube minus 1. Now 23. 23 can be written as 3 cube minus something. So as the second term is 2 cube, I am taking third term as 3 cube minus something. So 3 cube minus something, that something is nothing but 4. So 4 can be also written as 2 square. Now let us look into this 55. After 3 cube, we'll consider 4 cube minus. So 4 cube is nothing but 64. 64 minus 9 will give you 55. So 9 can be written as 3 square. Now fourth term is 4 cube minus 3 square. Third term is 3 cube minus 2 square. Second term is 2 cube minus 1 square. And the first term, 1 can be also written as 1 cube minus 0 cube. So clearly we can say that this series is following a pattern n cube minus n minus 1 square. Now look into the term which we require. 1, 2, 3, 4, 5, 6, 7, 8th term. So the 8th term can be written as 8 cube minus 8 minus 1 square, which is 8 cube minus 7 square. If we simplify, the value will be 463. That is option C. We have to find the sum of all the numbers between 47 and 899, which when divided by 7 leaves remainder 1. So between 47 and 898, first of all we have to find the numbers which when divided by 7 leaves remainder 1. Now we know that 49 is exactly divisible by 7. So if we add 1 to this, that will be a number which when divided by 7 leaves remainder 1. The first number of the series is 50. Next number will be 50 plus 7, that is the number by which you have to divide. Next 64 and so on. Last number will be 898 when divided by 7. Check what will be the remainder. If we divide this, remainder will be 2. But we need the numbers which when divided by 7 leaves remainder 1. So remove 1 from this. So that will be 897. So clearly this is an arithmetic progression whose first term is 50, common difference is 7, and the last term is 897. Now in order to find the sum, first we have to know the value of n, that is the number of terms. Now as we discussed earlier, how to find the last term? How to find the nth term? Last term, that is 897, minus first term, that is 50, by common difference plus 1. Now n will be nothing but 122. Now how to find the sum to all these terms. Sn is equals to n by 2, which is 122 by 2 into a plus l. A is nothing but the first term, which is 50, plus l is nothing but the last term, which is 897. If we simplify, the value will be 57767, which is nothing but option B. In a sample of certain germs, initially there were 1000 germs. Now, after every 30 minutes, they are tripled. So, initially in this sample, there were 1000 germs. So, after 30 minutes, they will triple. That will be 3 into 1000. Now, can we write this 1000 as 1000 into 3 power 0? Now, this can be written as 1000 into 3 power 1. Now, after this, after next 30 minutes, the number of germs will be 3 into the previous term, that is 3 square into 1000. Now, clearly we can see that this is forming a geometric progression. So, after 30 minutes, that means after one transaction, it is 3 power 1 into 1000. Now, after two transactions, it is 3 square into 1000. Now, we need the number of germs after 180 minutes. 180 minutes is nothing but 180 by 30 after 6 transactions. So, after 6 transactions, the number of germs will be 3 power 6 into 1000. Because first transaction is, after first transaction 3 power 1 into 1000. In second transaction 3 square into 1000. Similarly, after the sixth transaction, it will be 3 power 6 into 1000, which is 729 into 1000, which is nothing but 7.29 into 10 power 5. That is option A. Find the sum to first 12 terms of the series whose nth term is given as 2n minus 10. Now, nth term, that is Tn, is given as 2n minus 10. We have to find the sum to 12 terms, that is S12. Now, we know the formula. S12 is nothing but n by 2 into a plus l, where a is the first term and l is the last term. Now, S12 can be written as n is 12 here. 12 by 2 into a will be first term, that is T1, and l will be 12th term, that is T12. Now, from this Tn is equals to 2n minus 10, we can clearly find T1 as well as T12. Now, T1 is nothing but 2 into 1 minus 10, which is minus 8. Similarly, T12 is 2 into 12 minus 10, that is nothing but 14. Therefore, S12 will be 12 by 2 into minus 8 plus 14, which will be equals to 36. So, the option B. The nth term, 100th term of the series, 2, 5, 10, 17 and so on. Now, just look into the numbers. Now, the first number is 2, which can be written as 1 square plus 1. Now, look into the second number, that is 5, which can be written as 2 square plus 1. Similarly, the third number can be written as 3 square plus 1. Now, look into the next number, 4 square plus 1. The series is in the form of n square plus 1. Now, if it is the first term, it is 1 square plus 1. Second is 2 square plus 1, so on up to nth term. Now, we need the 100th term. So, obviously, 100th term will be 100 square plus 1, which is nothing but 10,001. That is option B. We have to find the common ratio of a geometric progression whose 6th term is 3 and 10th term is 243. Now, we know that in a geometric progression, nth term is given by a into r power n minus 1. So, the 6th term T6 will be nothing but a into r to the power of 6 minus 1, that is 5, which is given as 3. Similarly, the 10th term, that is T10, is given as a into r power 9, which is equals to 243. Now, let them be some equations 1 and 2. Now, in order to find the value of r, it is enough to divide this equation 2 by equation 1, which is nothing but a into r power 9 by a into r power 5 is equals to 243 by 3, which is nothing but r power 4 is equals to 81, which can be written as 3 power 4. So, clearly we can say that r is 3, which is option C. It is given that arithmetic mean, that is a, of any two numbers is given as 80, and the harmonic mean of two numbers h is given as 45. Now we have to find the geometric mean, that is G. Now, we know that arithmetic mean, harmonic mean and geometric mean will be always in geometric progression. So the relation between A, G and H is nothing but G square is equals to AH. Now, in order to find the value of G, it is nothing but root of AH, which is equals to, we know the value of A and H, just substitute them, 80 into 45. If we simplify the square root, the value of G is nothing but 60, which is option A. Series is given as 60, 57, 54 and so on, which is an arithmetic progression. We have to find the maximum sum of this series. Now, by looking into the series, we can say that the given series is multiples of 3 in descending order. So, if it is a multiples of 3 descending order, so it is 60, 57, 54 and so on. At some point, we'll get the value as 3, then 0, then minus 3, minus 6, minus 9 and so on. But we have to find the maximum sum. In order to find the maximum sum, it has to be all the numbers in the series must be positive. So we cannot take this 0 or negative numbers. So in order to find the maximum sum, it is enough to add these numbers 60, 57, 54 and so on up to 3. Now clearly they are in arithmetic progression whose first term is 60, whose last term is 3 and the common difference D is nothing but 3. Also N is nothing but 20. Simply it is nothing, 3 is nothing but 3 into 1, 60 is nothing but 3 into 20. So obviously there are 20 terms. Now how to find the sum to 20 terms? S20, that is N by 2 into first term plus last term, which is 20 by 2 into first term is nothing but 60 and the last term is 3. If we simplify, the number will be 630. So the maximum sum is 630, which is not given in any of the options.